Okay, so with question 2, it says a car moves with constant acceleration along a straight horizontal road. It passes the point O with speed 12. Okay, so we know the initial speed is 12. It then passes point A 4 seconds later with speed 32. Okay, so you can think of this, if you like, as like a road here. Okay, we can even draw it in. Okay, like a journey there. So at O, it's got the speed 12. 4 seconds later then, it's got the speed of 32 at A when t is equal to 4. Okay, so it says then in part A, show that the acceleration of the car is 5. So using v equals u plus at, okay, the Suvat equations there. Well, we've got v to be 32, we've got u to be 12, we want to work out a, and we know that t is 4, okay? So we've got all the values there apart from a. So what I do then is I take that 12 over, and on this side then I'm left with 4a, okay? 32 then take away 12 is 20, equals 4a. And then a would equal to 20 divided by 4, which is equal to 5 meters per second squared as required. Part B then, it says determine the distance OA, okay? So to get the distance, of course, we need S, yeah? That's what we need there, the distance. So we can use, well, there's two formulas we could potentially use. I'm going to use the S equals half u plus vt formula, okay? We could also use v squared equals u squared plus 2as. We could use that there. Or we could use s equals ut plus half at squared. So there's three formulas, in fact, we could use. So s will equal to half. Now the initial velocity is 12. Final velocity is 32. And this happens over a period of 4 seconds, of course. So it's just a case of working that out, okay? We can work it out in our calculators, and you get 88 in total, right? 88 meters. Part C then, it says the point M is the midpoint of OA. Calculate the speed of the car as it passes M. Give your answer correct to 1 decimal place. So M essentially, right, is bang in the middle there, okay? So, you could even sort of measure this out exactly so we get a good perspective. The M is about there. Okay. Now let's see what we know here, okay, because we want the speed here, don't we? Okay, we want to know what V is here. So, we know the initial speed is 32, so that's guaranteed. We know the acceleration is 5, right? We worked it out, and it confirms in the question, doesn't it? That's what A is. Let's think about what else we know. Well, we know the distance, don't we? Is 88. So halfway, the distance is going to be 44, yeah? So it'll be half times 88, which is 44. Is there anything else we know? I think that's it, isn't it? Be careful not to fall into the trap to think the time we know, because we don't actually know the time, all right? It's 4 seconds to get from O to A. It doesn't mean it's going to be 2 seconds to get to the midpoint. Okay, you've got to appreciate that. This vehicle is speeding up, okay? It's speeding up. So it'll get to the halfway point, okay? But it'll be going even faster for the second half of the journey, okay? So it doesn't mean it takes it 2 seconds to get to the halfway point. Probably takes it longer. Probably takes it longer than 2 seconds. But the last half is going faster, so it doesn't take so much time. So don't cut that time in half, right? Because it won't work like that. You've got to think about this logically. So we want to find V, okay? We want V. Now let's think about what formulas we could use. Now we know U, A, S, and we want V. So the formula I'm thinking of is V squared equals U squared plus 2AS, okay? Now V will be our velocity at M, right? So plug it in, 32 for U. Acceleration is 5 and S is 44. Okay, so we'll work that out. 32 squared plus 2 times 5 times 44. That comes to 1464. And of course, then to get V, I need to square root, take the positive solution, of course, because I want the speed here. So that comes to 38 point, and to one decimal place, 38.3 meters per second.